To our webinar, 5 Important IT Capacity Management Trends for 2012. I'm Frank Days from Correlsense, and on behalf of both the Correlsense team and the folks from Metron-Athene, we welcome you to our webinar. Before we get started today, I just wanted to take a moment to go through our agenda. First of all, we'll do a quick update on capacity management today. Then we'll go through the meat of the presentation, which we'll talk about the 5 trends, which I think most people are pretty interested in. Then we'll go into the joint SharePath and Athene solution to try to help you meet some of these trends and needs today, followed by a short demo and a question and answer period. The presentation today we'll try to keep to around 40 minutes to leave you with some time at the end of the hour. Do feel free along the way to submit questions via the chat window. We'll try to take the questions along the way rather than waiting till the end. And finally, we'll be making the slides as well as the recording of the presentation available on the Correlsense website tomorrow. Now, without further ado, I'd like to hand the telephone over to Rich Fraunheiser from Metron-Athene, who will talk about our trends.
Thanks, Frank. Hi, I'm Rich Fraunheiser. I'm with Metron-Athene. I just wanted to welcome everyone to the webinar. I'm going to talk about capacity management today. Our company, Metron, is we're solely focused on capacity management. It is the only thing that we do. We do capacity management, services, software, and training. And we have an exciting partnership with Correlsense in order to provide a combined solution that I think is one of the most unique and certainly the most valuable in the area of application performance management and capacity management. So I want to talk a little bit about what the current state of capacity management is, and I really like looking at things this way because this really aligns well to ITIL, and I'll talk about ITIL a little bit later when we talk about the 5 trends for capacity management. There are really 3 subcomponents to capacity management. There's the business subcomponent, the service subcomponent, and then the component area as well. And it's broken down into these 3 ways. When we look at the business, we have to look at how the business is changing and how we have to adapt to provide adequate capacity and adequate performance based on business changes and business trends. There's constant changes in the business. There's constant merger and acquisition activities. And these type of activities can be game changers for businesses. And if businesses aren't prepared in the areas of providing good performance to transactions and applications, as well as having adequate capacity to support those transactions and applications, mergers and acquisitions are going to go much more difficult than they should, and could actually hurt the business in quite a way. So, being able to look at business activities and being able to adapt to those and have IT underpin those business changes is incredibly important. At the service level, we're looking at complex multi-tiered architectures, service-oriented architectures. We're looking at applications that are a lot more, and services that are a lot more difficult to understand, a lot more complex than they used to be. And that provides an enormous challenge for capacity management and application performance management. And then the component level. It used to be that we would look at things like servers, disks, networks, mainframes, etc., and we would look at those individual components, and if those components had adequate capacity, if things were running well on those components, it was a pretty good bet that our services and our applications were going to run well. Unfortunately, these days, with a very dynamic, heterogeneous environment that includes virtualization, that includes cloud computing, there's no way to take a look at one piece of hardware and say, this is running well, therefore the application and services are going to run well. Now we have to have a much bigger picture view of IT, where we look at the overall capacity that's available, the overall flexibility of our environment, and we have to be able to meet our service level agreements while managing this very complex cloud-oriented, virtualization-oriented environment. So the 5 trends we're going to look at today, we're going to break capacity management down into what we see are 5 trends for 2012. And some of these aren't what I would consider to be new trends, but they are things that are going to be very important this year and in years going forward. The 5 trends that we've identified are IT cost and service level agreements. Service level agreements, incredibly important that we are able to not only define a service level agreement. I think everybody is pretty good at defining a service level agreement. It's really easy to say that we want 95% of our transactions to complete in 2 seconds. The real challenge from a capacity management perspective is being able to measure, monitor, and police those service level agreements. I've taught a lot of courses, capacity management practitioner level courses, and one of the chapters that I frequently do is on designing a good service level agreement, even though that doesn't specifically fall within the process of capacity management within ITIL. It's usually left to the capacity and availability managers to monitor and police service level agreements. So if a service level agreement is defined that is meaningless because you can't measure, monitor, and police that agreement, it's really a worthless process. And that's why SharePath, which we're going to talk about a little bit later, is so exciting to the capacity manager because it gives us the tools to be able to adequately police those service level agreements. We're going to talk about physical to virtual environments. A lot of environments in organizations today are moving to virtualization. A lot have already moved a dramatic amount of things to virtualization, but that brings us additional challenges in the area of capacity management. We'll talk about cloud-based environments, which is in some ways an extension. In a lot of organizations dealing with things like private clouds, it's just an extension or maybe even a renaming of virtualization. But there are also some other clouds that are being managed by outsourced clouds, things like public clouds, hybrid clouds, and that causes some additional challenges as well for capacity managers. It really forces the capacity manager to think differently about what they do and how they provide value to the organization. We'll talk about virtualized applications. We'll also talk about the ITIL methodology. ITIL is the IT infrastructure library. It's a process-based methodology where it went from version 2 of ITIL, which was very process-oriented, to version 3, which is much more of a service lifecycle orientation, but aligning your processes to a best practice approach like ITIL can really help make your capacity management process considerably more effective, and organizations will recognize the return on investment from that type of methodology. Okay, so let's look at the 5 trends in turn. We'll look at first of all, we'll look at trend 1. We'll talk a little bit about IT cost and service level agreements. Pretty much these days, IT professionals, you really need to conduct some kind of a cost-value analysis, and that has to do not only with the hardware you're buying, the software you're buying, the people that you're employing. It also has to do with the processes that are in place as well. Facilities and energy costs are going to consume more budget. We talk quite a bit about green computing. Metron as a company, as a capacity management organization, has been heavily involved in the move toward more green computing. Because face it, if you're going to consume less, if your goal is to consume less energy and to take up less space from a facility standpoint, one of the best ways to do that is to properly size your environment, and that's where capacity management comes into play. New application environments make service level agreements more challenging. It was easier back in the days of dumb terminals and mainframes to design a service level agreement because you could measure the amount of time that a transaction took on the mainframe just from the data that came from the mainframe. But in this distributed, virtualized cloud environment, it's much more difficult, and really that's where SharePath comes into play, because SharePath is able to go in and measure those type of numbers to get those application response time numbers, transaction response time numbers. So to manage service level agreements, we need to look at a number of things. We need to be proactive. We need to go beyond just load testing. Load testing is a wonderful tool to help you figure out what type of hardware you need, whether or not there are issues within applications, performance issues, bad code, etc. But you need to go beyond that. You need to actually look at your production environment. You need to look at the response times from the view of your end users. And many of your end users might actually be sitting out on the internet at their homes. And you need to be able to figure out what type of response time those folks are getting. And you need to keep an eye on your worst transactions. By worst transactions, I would look at that in a number of ways. I'd look at ones that tended to perform inconsistently, ones that, some transactions, some of a particular transaction type, some of them took a long period of time, some of them took a short period of time. I'd also look at it as the ones that consume a considerable amount of time, because if those get worse, those tend to be the most noticeable. If you have a transaction that only takes 1/10 of a second and it goes to 0.15 of a second, well, that's 50% degradation, but probably very few people are going to recognize that. But if you go from 2 to 3 seconds or from 10 to 15 seconds, it's the same percentage degradation, but people are probably going to notice that a lot quicker. So one recommendation we can make out of this is to keep an eye on your top 10 killers. Take a look at your applications. This is a screenshot coming from SharePath. And here we're looking at a series of transactions and their response times. Also, we're looking at whether or not they're currently meeting their service level agreements, whether they're close to not meeting their service level agreements. These are all defined within SharePath. What is the service level agreement for this particular transaction? It's important to keep track of your applications, your transactions, so that you know whether or not you're potentially close to having a performance or capacity issue. Or if you currently have one, it gives you a place where you can look and drill down further. Trend 2 that we're going to talk about today has to do with moving from physical to a virtual environment. Okay, firms are continuing to migrate from, they're continuing to go from physical to virtual. Virtual environments are much more complex than the traditional physical environments that we're all used to. And the cost of unexpected errors during migration can be crippling. So imagine that you have existing physical environment where you have hundreds of applications that you want to move into a virtual environment. If something goes wrong with one of those applications, it's not necessarily a good thing, but it's only going to affect probably that one particular application. If you move into a virtual environment and you have inadequate capacity because one application grows by leaps and bounds and you're not managing that environment well, or when you're migrating into that virtual environment, you don't manage that process well, you could potentially affect all 100 of those applications and potentially catastrophically affect your entire business. The tip that we want to give here is, understand your complete IT infrastructure during the migration. The key thing is to monitor critical application performance in the physical environment before you move to the virtual environment. So if you don't have monitoring in place in that physical environment now, there's really no way to even have an idea what your end goal is when you get to the production environment in the virtualized arena. You need to understand the end user experience now so that you can plan and predict and forecast what you want the end user experience to be in that virtual environment. And once you do migrate to that virtual environment, you need to continue to monitor. You need to verify the performance. You need to go back and validate all of the forecasting and the modeling that you're doing when you move to that virtual environment. So it's really important that you know what the experience of your end users are. It doesn't really matter where they are. It could be somebody in your data center, or it could be a grandma sitting at a laptop that's doing business with your online banking application who gets very frustrated because she's not sure whether it's her issue using the application or whether there's some kind of a performance or capacity issue. You need to know who your end users are, you need to know where they are, but also you need to know what their experience is in terms of how much time it takes for them to complete their transactions. The third trend that we're going to look at today has to do with the cloud-based environments. Cloud is not going away. It's going to continue to grow. You need to assume some type of a multi-tenant model where capacity will no longer be dedicated to finite groups of users or processes. Capacity now is going to be more of a a global view of the amount of capacity available. Rather than looking at finite pieces of hardware, now pieces of hardware are being clustered together in order to provide a more global, flexible model of capacity. So we need to know how much overall capacity we have. We need to know how much is being consumed. We need to know how each of those services applications are using the capacity and the potential for any one of those to consume more capacity than is available. One thing that we can do is provide cloud bursting. That can provide an efficient option. It provides temporary capacity needs, but you need to know exactly how much flexibility you need to have in place in order to provide that temporary capacity, whether you're providing cloud bursting through some type of an outsourcing arrangement or whether you're actually just keeping excess capacity available in order to provide additional capacity on demand. All of that is very important. And what it does is it really moves the capacity manager from a very deep level in the organization where we're looking at individual disks, individual CPUs, individual servers, more into a global view where you're looking at overall capacity, overall headroom. So capacity planners will need to update their skills. And I would also argue that capacity planners will also need to update their mindset. We need to worry less about individual processors, and we need to worry more about the global effect of capacity. Capacity monitoring tools are improving to deal with this trend, and tools like Athene and SharePath, especially when used as an integrated solution, enable us to not only look at the resources that are being used, but also take a look at how individual transactions are performing as we make changes to our environment. All right, so when we look at cloud environments, we want to monitor the entire IT infrastructure from end to end, and that's not easy to do because of all the different layers we have these days. So we want to watch every transaction, and that's where SharePath comes into play. SharePath allows us to look at each transaction, and now we're not talking about a sample of transactions. We're not talking about synthetic transactions. We're talking about every real production transaction that is being run is being measured, monitored, and we're checking to see whether or not it's meeting a defined service level agreement. Very important these days because a lot of tools that are out there these days will use synthetic transactions. They'll rely on things like load testing. They'll just do a sample of transactions, maybe from just a couple of different geographies. But what that does not do is adequately measure the real end-user experience that people are getting. So very key that we monitor the entire infrastructure from end to end. The fourth trend has to do with virtualization and virtualized applications. Application environments are increasingly complex. I've been involved in capacity management now for over 15 years, and I started as a capacity planner when I came out of graduate school. I've moved into vendor land over the last few years, but the difficulty that I faced as a capacity planner, things used to be a lot easier. We had client-server applications back then, but they were, one client going into one server, and as long as everything was going well on the server, you could pretty much guarantee that everything was going well for the end user. It's not quite that way these days. We have web servers, DB servers, app servers, identity servers. We have different platforms, Java, Windows, Unix, mainframes. We have a whole bunch of centralized storage, SAN environments, NAS environments. We have different types of networks, virtualized. We have LANs, WANs, etc. Things change. Doesn't matter what application you have. You have busy times of the day. You have busy times of the month, year, etc. And one thing that we've noticed is that organizations have a lot of tools. There are a lot of companies out there that I call serial tool acquirers, and a lot of those companies have really not implemented any of those tools in an effective way that are either integrated or provide any kind of real end-user insight. So taking a look at all of this, we need to have some type of a methodology, some type of an approach where we can get valuable information and use the valuable information in order to manage our environment. So what does it really take to manage this type of environment? I really like this line of thinking here. Be paranoid, be smart, be lazy. And you really do need to be these three things at once. And now, how do you be paranoid, smart, and lazy at the same time? You're paranoid if you're willing to watch every transaction from every user. Now, of course, you can't sit and watch every user submit a transaction and watch what their response time is by looking over their shoulder. I've done that. I've actually sat behind somebody who was complaining about performance with a clipboard and a stopwatch and measured the response time. It was an effective thing to do. It wasn't an efficient thing to do. And it's impossible to do, again, that's just sampling. It's impossible to do that unless you have some automated process in place that allows you to do that. And you do need to do that. Be smart is understanding what's happening across the time-space continuum. And now, what do we mean about that? Well, when we're talking about space, we're looking at different geographies. If you have a transaction that is being submitted by people all over the world, and there's only one place where that particular transaction is causing complaints, or sitting outside of the service level agreements, or there's a big cluster of applications coming in from that particular transactions coming in from that particular geography. It's important to know that. It's important to be able to drill down and say, in this case, only the people in Houston are having problems. They're the only ones that are not meeting their service level agreements. Maybe that gives us the ammunition then to go and do some troubleshooting and find out, maybe there's some faulty networking equipment. Maybe there's a server that's down in that particular geography. We need to be able to know where things are happening. More importantly, or equally as important, we need to know when things are happening as well. If the application itself is busy over a certain hour of the day, 15-minute period of the day, and that the intenseness of that application is causing performance issues where we need to provide additional capacity for that particular time period, we need to know that. And as you can see from the last two screenshots, SharePath provides the ability to know not only where things are busy or where we're not meeting SLAs, but also when, both being incredibly important. And by be lazy, so we're being paranoid by looking at all the different transactions. We're being smart by looking where and when. We're also going to be lazy by automating the process. It is impossible these days to do this without automation. So we're going to set service level agreements, and we're going to get a text message or a page or an email or something when there's a problem. It doesn't matter how complex the problem is. Back in the day when I started this, I used to have to monitor about 12 servers. And it sounds ridiculous when I say that now 15 years later, but I really didn't need an automated process to look at 12 servers. When I'm looking at 12,000 servers, I better have an automated process in place. So we do that by looking from the perspective of the end user and setting real service level agreements that we can then monitor and police accordingly. The last trend I want to talk about today is the ITIL methodology. And this ITIL methodology means that when we look at the capacity management process, it concerns all the technologies across the data center. We're looking at making sure that all of our processes align at the three subcomponent levels: business, server, service, and component levels. We want to make sure that we have iterative activities in place, which are monitoring, analysis, tuning, and implementation. We want to make sure that we have a capacity management information store where we have information that's stored historically so we can see where our busy periods are. We can get a baseline. We know that when we forecast going forward, it gives us a scientific approach for figuring out exactly what hardware we need to buy in the next year. New delivery platforms will continue to impact this. software as a service, infrastructure as a service. Those types of things will change the way we look at capacity management from an internal perspective. If we're signing a contract with somebody to provide software as a service, from a company perspective, we just want to be able to have confidence that when we flip the switch, the computing power we need is there. But unless we know if we're meeting the unless we know whether those transactions are meeting the service level agreements, we really don't know whether the outsourced the company we're outsourcing to is meeting their service level agreements. So having an ITIL methodology in place, having the tools in place in order to measure and monitor, very, very important. So how to implement ITIL methodology? Some type of real-time detection is important. Transaction monitoring, mapping, and modeling. This is another screenshot of SharePath. This provides a more topological view. A lot of different layers now in our IT infrastructure, but what SharePath is able to do is it's able to look at each one of these components. So if you have a transaction that goes through firewalls, proxies, web servers, application servers, ends up back in a mainframe database, you need to know how much time is being spent at each one of these hops, because if you don't know how much time is being spent at each one of these hops, it makes it very difficult for you to figure out where your performance challenges are and where the areas for improvement are. All right, so moving on into the demo area of the presentation, we're going to talk a little bit about, and I've shown some shots from SharePath already. I haven't shown anything yet from Athene, so I'm going to show some screenshots from Athene where we actually take some valuable data in from SharePath. SharePath can provide data that we can incorporate into the Athene's capacity management information store so that we can correlate end-user transaction response time numbers back with resource usage from individual pieces of hardware or groups of hardware. So it's very valuable information. We'll talk a little bit about how SharePath in that way integrates with Athene, how it can be used in the real world for a scenario, and then what value it adds. We're going to look at two scenarios as part of the presentation. We're going to look at an online trading application and an e-banking application. They're hosted on multiple Unix and Linux servers. What we have here is the ability with SharePath data to bring this information into our Athene database for reporting, for trending, and for alarming. In this particular case, we're looking at average response time in seconds. So what we're taking are actual end-user experiences for all of the transactions that are being submitted over the course of a particular time period. We're averaging those, and we're getting a view of what the average response time is over a particular time period. And you can see that for a number of hours during the business day, we're exceeding our service level agreements, and not coincidentally, that is pretty much during almost the entire business day. So what we're finding here is we have an application that is not meeting its service level agreements during the business day. So that's an opportunity for us to provide additional capacity and fix this particular problem, and we're going to do that by the process of modeling, and I'll show you that a little bit later. We can bring data in and show different types of transactions that are being submitted. We have 4 different types of transactions here. We have customer attributes, we have equity orders, order routing, and then risk analysis type of transactions. So these are the online trading total transactions by those particular types stacked on top of one another so you can see what the transaction mix is over a particular time period. This I find to be a pretty powerful message as well when we talk about capacity with management folks, because you can tell a business manager that your CPU is 92% and that's a problem, and their eyes will start to glaze over. It's more important to try to put information in business terms that people can understand, where if we say that if we exceed 70% CPU for this particular system, our average response time is going to exceed the service level agreement, so we need to provide more CPU power or more processing power. That type of information is much more useful because you can actually relate it to them in terms of what their response time is and the fact that they're not meeting their service level agreements. Okay, so we're going to talk a little bit about what modeling is. If you've never worked with a capacity management model before, a model in general is just a simplification of reality that's built for a specific purpose. In other words, we're taking a very complex situation and we're going to simplify it to what we consider to be the most meaningful parts so that we can make predictions of activity, response time, performance going forward. An example of a model would be, I have a system right now that's performing in a certain way, but what happens when I double the number of users on this particular application? What will the effect be on this particular system or group of systems? That would be some type of a predictive model that we would build within capacity planning. There are different ways of doing modeling. One way that ITIL talks about modeling as a generic process where there are different ways of doing modeling. One of those is simple linear trending. There's a problem. Linear trending is useful in a number of ways. It's great when you have things that change linearly or there's no discontinuity in any way in an environment. If you trend up to 70% CPU, you alert on that. That's something that actually can be automated fairly easily. So, you know, if I have a trend line put on a particular server's CPU utilization and it hits 70% in the course of the next 3 months, alert me. I can get a pretty proactive alert at that point. I can make some capacity management decisions. The only problem is when environments change, when things change, trend lines really get out of whack. Trending is the kind of thing you can very easily automate, but if you don't carefully look at it, you can get some results that are not desirable. In this case, you can see on this slide that this is a server that was probably upgraded at a certain amount of point, or a certain amount of work was offloaded. And what this is showing us is the fact that when that step change happens sometime in February, what it does is it throws the trend line off. The apparent trend is the red line. The real trend is the green line. If you work off the red line, you're probably going to run out of capacity and you're going to have performance issues because you weren't careful enough to look at how things had changed over time. So trending can be a real useful tool, but it can also be kind of dangerous if you don't do it in an intelligent way. Another reason why trending can be difficult is because response times are nonlinear. That makes sense. There's a lot of what we call queuing theory underneath all of this. It's a branch of mathematics that's underneath this. Response times are nonlinear. That makes sense if you think about it. You know, if I have a computer that has a certain amount of processing power and I start to use more and more of that processing power, everything that I do is going to take considerably longer to get done as I run out of processing power. Things have to wait to actually get processed. And as we get closer and closer to 100% utilization, response times degrade in a drastic way. It's a nonlinear change. It kind of has the view of this curve that you see on this chart. Things move fairly linearly until you hit the knee of the curve, and then things fall apart. And you need to be able to predict when things fall apart. So modeling is a very analytic modeling or mathematical-based modeling is a very important tool in order to be able to predict future computer performance. Some of the challenges in modeling is understanding which servers are hosting the applications. We need to know the relationships. There are suites of applications out there now where there are 40, 50 servers involved, and we need to know how those servers relate with one another. We need to understand the business volumes. You know, what time of the year are you busiest? What time of the week are you busiest? What time of the day are you busiest? We need to understand the resource consumption. How much of the resource consumption is being done by the application, by the transactions that we're really interested in, and how much of the resource consumption is being done by things like overhead. And then accurately assigning resource usage. What SharePath can really help with in this process is accurately capturing the workload split, because we can look at the number of transactions that are being done in a particular category, and we can build the workloads accordingly when we build our models. So the two products work extremely well together in that way, in a very integrated way. Some screenshots from Athene now. We have we have a baseline model here where we're looking at different workload components. We have the e-banking, we have the online trading, and what we can see is that the server itself, and apologies, the slides are somewhat small here, but the lower left-hand corner, you can see that the CPU is between 80 and 90% utilized during the time period that we're looking at here. And essentially what that means is that there's going to be a fair amount of CPU queuing, and that's represented by the red in the bars. It's not possible to eliminate all queuing within a system, but minimizing the amount of queuing means that you're going to get the best performance for your transactions that you can expect to get based on the power of the hardware. So, the goal is to try to minimize two things you can do. You can provide additional resources, additional processing power, or you can change the way the application works. And more likely than not, you're going to increase the amount of power that's available here. So we can see that maybe we want to improve by putting some different scenarios in place, mathematical scenarios where we can predict how things will change when we either upgrade the system or we move work and offload some work onto a second system. And those are the scenarios that are shown here. The baseline system, again, is where we're above 80% CPU. When we move some work off the system, it drops the CPU percentage down to 50. When we upgrade the existing system, it still keeps us underneath our service level agreement, or our really it's more of a performance threshold at that particular point, where we're setting thresholds at 70 and 85% because we know that if we exceed those, we're going to endanger or not meet our service level agreements. You also see that the amount of queuing went down drastically in that particular slide as well. A lot less of that bar was red and a lot more of that bar was blue, and that's the result that you get when you eliminate or minimize the amount of queuing that's being done. Another scenario, obviously, not only do you have to deal with situations where maybe you're not getting good performance, but you know that going forward there's going to be considerably more users to an application or a system. In this particular case, we're modeling projections for the next 4 quarters of the business. And you can see that when we take the existing hardware and we model growth, we're going to really exceed those performance thresholds. So we can incorporate not only growth into this modeling scenario, but upgrading the hardware as well. And then what we get in the bottom right is the projected relative service level for the online transactions. The baseline period is normalized at 1 so that we can easily see how much what percentage these transactions will degrade in terms of responsiveness. The Q1 projection, we see about a 25% degradation in response time. Q2, we're seeing a more than doubling of response time, which is certainly going to be unacceptable in this environment. But when we upgrade the system for Q3, we've actually improved the environment to the point where we're doing better than we were back at the baseline period, even when we add the Q4 projection back into the process. So modeling is an important tool, and the data that comes from SharePath is an important set of data that can help us refine our models when we build them. Okay, so we've reached almost the end of the presentation today. Just a quick summary. To manage the 5 trends that we have, you have to really understand your entire IT infrastructure. And I really see Athene and SharePath as 2 tools that you really need to have in the kit, and the integration pieces between them as being very important, because what SharePath is going to allow you to do is understand every transaction and monitor every hop of every transaction. What Athene is going to allow you to do is capture vital resource statistics, store them in a historical manner, allow you to summarize and aggregate that data, and then do things like analysis and modeling on a resource level. By using SharePath to fully track transactions, Athene to optimize capacity management, all of this really allows you to provide better capacity management decisions and predictions going forward. And I will pass it back to the host.
Great. Well, thank you, Rich. A great presentation. Again, as I mentioned earlier, we were taking questions via the chat window. I don't see any questions at the moment, but if you do have any questions, do feel free to send through the chat window. And in conclusion, I don't see any questions coming through. If you should have any questions about anything that Rich or I covered in this presentation today, feel free to send us an email at info@correlsense.com. Certainly from a product standpoint, you can learn more about Metron-Athene's products at metronathene.com, or take a look at the demo of Correlsense's product at correlsense.com/demo. And finally, if you're interested in Correlsense's real user monitoring product, realusermonitoring.com, you can download a free copy of SharePath Real User Monitoring today. Well, on behalf of Rich, myself, all the folks here at Correlsense, as well as Metron-Athene, thank you for joining us today. Once again, we'll be posting the slides tomorrow on correlsense.com. Look on the home page as well, and we'll try to email people once they're up there. Thank you, and have a great day.